my name's Hazem Gaber, and today I'm going to tell you what you need to know about the Wonder Valley Data Center project. So, first of all, it sounds like a salad dressing, but in all seriousness, it's a plan to build the largest data center and AI tech campus in the world south of Grand Prairie. It's going to be worth over $70 billion, and it's going to be powered by natural gas because that's what's in the ground there. And at its peak, it's going to use 40% of Alberta's electrical grid, which is impossible. It would drive the electrical prices through the roof. So it has to produce all the energy locally and give it to the data centers that are going to be built there. But the biggest problem with this is it's not clean. And tech companies want to use clean energy, so they found a solution, which is to turn the natural gas into methanol, and the methanol is burned and the carbon is captured and stored in the ground, and some of that methanol can be used for production of solvents, automotive fuel, and clean manufacturing. And it's got fresh water according to the engineering studies, and it's also got a large railroad running through it, which is good for bringing in supplies. And they're building a road. The road's not ready yet, but they have started clearing the trees. But the biggest disadvantage of this project is where it is, because it's 50 kilometers south of Grand Prairie. Now, how are you going to convince an artificial intelligence genius from San Francisco or San Jose or even Calgary to come live in a forest in like a camp like you would get in Fort McMurray, basically like a 200-300 square foot a house, or if you call it a house, it's not really a house. It's almost impossible because tech company workers want to see a beautiful campus like this. So in order to attract tech company workers, you gotta have not just great pay, but you gotta have a beautiful campus, which may or may not be possible up there. And even then, they're going to be far from their families. So it's quite a stretch to think that you're going to have this many people, unless you manage to build a whole big city overnight and bring all those people in as a critical mass to live up there. But that brings its own challenges, including waste disposal and utilities and all that stuff. So it's not really likely that this is going to be a hub for tech companies. More likely, it's going to be a hub for data centers. And data centers, they don't create a lot of jobs, okay? They create maybe 9 jobs per data center. Now, during the construction phase, there's a ton of work for electricians, HVAC technicians. They have to install a ton of cooling systems, a ton of batteries, a ton of UPSs, a ton of data cable, a ton of electrical distribution. But after that, what you end up with is like 2 or 3 security guards, contractor security guards who make $18 or $22 an hour. Usually they're billed out at $28 an hour. And you get contract technicians who come in to replace the hardware when it fails. The hardware is super redundant in a good data center, and these people, they don't make that much money either. They just don't, because their job is basically to replace the parts, and if there's any programming or configuration involved, that usually happens remotely from India. So, this brings me to my next point, which is that if we need a tech to get out there really fast, it's going to be impossible, because the nearest qualified people will be 4 hours away in Edmonton, and replacement parts will also be 4 hours away in Edmonton. So that brings a significant risk to building a data center that can be redundant, because there's not enough support staff to get out there fast enough. Typically, when we build a data center, we want to put it close to the population that it serves. So we put data centers in the most dense areas, because data centers have servers, and servers have applications on them, and the applications get accessed by the users. So the closer the user is to the data center, the better performance they have. Now, if we put a whole big concentration of data centers way up in the middle of northern Alberta and put a whole bunch of applications on them, and people in Grand Prairie will have a really great experience, but people all over the country are going to have a really terrible experience. And I bring to this point a fiber optic cable map. So this is a map of fiber optic cables in the United States, and they're owned by different service providers like Verizon, AT&T, Sprint, Windstream, and these fiber optic cables, where the circles are called peering points, and that's where multiple networks of fiber optic cables merge, and they use that merge point to exchange data. So if your data center is connected to an AT&T network, but your customer has a Verizon internet service, how do they get to your data center application? Well, data has to travel to one of these peering points and switch from an AT&T network to a Verizon network to get to you, or vice versa. And these fibers extend to Canada. And if we see the fiber optic cables, the main fiber optic cables are passing through very heavily populated cities, including Vancouver, Seattle, Edmonton, Calgary, Chicago, Ashburn, Virginia, Washington, New York. And so this is where most of the main data centers are located. They're located near these fiber optic cables because data center owners can buy what we call dark fiber, which is the right to use some of that capacity of these fiber optic lines between the different cities. So they can transport as much data as that line can handle for a flat monthly fee. We don't really have that kind of system up in northern Alberta where you can buy a huge capacity and dump all your data onto a peering point to get it to all the other networks. So from a practical sense, the fiber optic infrastructure isn't there to connect the data centers that they're proposing to build. Now, if I was a startup, I would just put my new app on like a cloud service provider like Amazon Web Services or Azure or even IBM Cloud, because I could go to aws.com and deploy the server hardware that I need in like 2 or 3 minutes, literally. And I will pay 11 cents an hour or $2 an hour or whatever hourly rate it's going to cost me to set up the hardware in the cloud, put my application on it, and be done. And I only pay for what I use. If I find I need 20 servers today, I can scale up to 20 servers. If I only need 1 server today, I can scale down to 1 server, and I only pay per hour for what I use. Versus coming out to a forest to put my application on doesn't make any sense. But if you look, here's another map of Amazon Web Services data centers, and we can see where they are. They're in Oregon, California, Ohio, Virginia, Sao Paulo. They're in the most heavily populated cities so that the applications have the shortest distance to get to their customers, where they don't have to cross through too many peering points to get from the data center to the final destination. And that's really, really important. Now, the other thing that you've heard is that AI uses 10 times the compute power, or in other words, a single Google search uses 1/10 of the power of an AI search, which is true. But that doesn't mean we're going to need 10 times the data centers, because according to Moore's law, computer power doubles every 2 years. So we're going to have 80 times the compute power in 10 years that we do now. And if you don't believe me, you can think about this. The compute power of like an iPhone 1 was the same compute power that they used to put a man on the moon. So as AI grows, compute power is going to grow too, and we might not need to have more buildings to house the computers that are doing the things that we want it to do. And here's another point, which is that ad revenue is not going to grow 10 times. Because if a Google search costs us, say, 1 penny, and the ad revenue is 2 pennies for that search, and now the Google search with AI, since it has 10 times the compute power, it's going to cost 10 times as much to perform that search. But the ad revenue is not going to grow to like 11 cents or 20 cents to keep the same margin. It's just not, because an advertiser is not going to pay 10 times what they're paying now, or 20 times what they're paying now to get for the same result, which is the same click, which is the same targeted user going to their site. So unless these companies figure out a way to get 10 times the revenue, it's really not going to happen that the AI is going to get that widespread to require 10 times the data centers overnight. So what's the solution? Building the campus up by Grand Prairie, where there's a lot of energy, is a great idea. It's a wonderful idea. But what we need to do is build some tech campuses in Calgary and in Edmonton, where we can attract startup companies to come and put their workers there. So they can put their data center up in Grand Prairie, where they can do experiments and run their apps. But we need actual tech jobs, people making, 6-7 figures per year, doing, maybe not very many will be making 7 figures, but definitely people making $150,000 to $200,000 a year, building applications and designing hardware. Hardware is big. Hardware is super important for AI. It's not just the applications, because everybody needs hardware. And we build a fiber optic network between the US and Calgary and Edmonton and the new campus. And this fiber optic network will give us dedicated capacity so that these applications can reach all of the end users quickly with very low latency and very few hops, very few peering points. And that will tremendously help the success of this campus. And we do something else, which is government gives free or reduced rent to these startup companies that come in, so they can have office space for a low cost, and they can have free or reduced compute resources. We can build a data center in the same model as like an Amazon Web Services cloud, where people can buy capacity on a existing computer system or a server. They can set up as many servers and storage appliances and devices as they need to test out their application, and they can pay a low fee or no fee if they are only buying a small amount of resources per month. And whatever intellectual property they export, we can tax, and in exchange we get a 2% stake in the startup that goes into Alberta government investment fund, and that stays property of the citizens of Alberta for like the next billion years. And out of all these startups, some of them are going to go bankrupt, and some of them are going to make an average amount of income, and a very small amount are going to make billions. That's what always happens. So 2% of several $billion is huge. And in exchange for getting this free rent and resources and our 2% stake, the startup guarantees to keep their headquarters here in Alberta, which guarantees a huge number of high-paying jobs here in Alberta, and it helps diversify our economy. So energy is great. We're blessed to have the energy, but what we really need are brains. We really need to attract more tech talent and more high-paying jobs here. If you have any questions or comments, I'd be happy to hear them. Thank you.